before we even open Materials Editor, let's talk a little bit about hierarchy. What's always a good idea is to create one master material that will control all the parameters. And then when you actually want to create material for a specific object or surface, you can create it as a child of that material. So let's get started with that. We can right click and create a material. And let's call it our material master. And here we can set up all the important materials parameter that can be later rewritten in a specific material instances of this master material. The reason why we are doing it this way is because we can make then global changes for all the materials and not have to go into every single material one by one and change them by that. We are saving a lot of time for our future selves. And let's get right to it. I'm gonna start with something very simple, and I would like to set up here some base color. I could do texture or whatnot, but I'm just gonna keep it simple, and let's put here just a free vector. There are shortcuts you should be aware of, and that's when pressing left click 1, 2 and 3 is gonna create you vector 1, 2 and 3. One vector is not actually a vector but a float, so that's minus infinity to plus infinity, any value in between, and it can be very useful for a bunch of parameters here. But right now we care only about free vector, which means simple vector that has RGB value, so we can set up simple colors. So let's just connect it here and change it right here from black to red. And now if I close it, I can simply right click on my material, create material instance. Let's call it m_demo scene. And let's do blue. But now if we open it, we can see that we can override here anything. We have just simple parent material that you can also change, which can be very useful to know. So now let's just open back our master material, and before we can change it, we have to turn it into a parameter. You simply do that by right clicking and converting to parameter. And we want to have this simple parameter called color. Now let's apply that, and if we run back into our blue, we can see here new parameter, which is a color. So let's just change this to blue. Now we can simply start putting it into our scene. You have a few ways how to do it. One is, for example, just clicking on it and dragging it right here. You can find it, blue, and you would be very easily able to find here a demo scene blue, or if you want a shortcut, you can just drag it there and apply. And there we can see they are starting to show up. It can take a bit because they need to compile. I would like to create a few more, so let's just duplicate our material instance. It will keep its parent connected, so let's just duplicate it, and this one should be red. And now we have these three materials implemented in our scene, and all of them, if we click on them and try to find them, we will see that they have the same parent material. So for example, I may want to change my mind now. I may want to switch this material into metallics because I want them to reflect stuff. So let's do that. There is few important parameters that you should be aware of. So first one is our base color, where you will either connect a simple color like I did here, or you can connect here a texture. Then we are going to add here a metallicness, which is basically how metallic the object is. Generally, it's recommended to think about it as either object is or isn't metallic. So think about it more as a boolean rather than flow. So it's either 0 or 1, not that much in between. But you can obviously find the values in between as well if you wish so. So let's just connect it right here and switch it to 1. And we should get some pretty nice metallic object. And if we look into our scene, it got applied to all our child materials, which is a huge benefit of working in this way, because now I can make global changes to all of my materials simply by changing it in my master material. And the smaller changes like here colors or specific parameters, I can change per material instance. That gives me much more freedom to do big and small changes very fast. Now we know about metallicness. It can be either metallic or non-metallic at all. Let's keep it metallic for now. And add our roughness. Roughness is another important aspect, and that's basically how much is it reflecting the world around it. And this you can think about as a regular float, so it's any value between 0 and 1. Let's add here a float that can control it, and remember the shortcut, number 1 on your keyboard and left click. That gives us a float, and let's right away convert it to a parameter. And call it a roughness. After we connect it in here, we can simply rewrite it. So as we can see here now, everything is very reflective, which is almost black because we don't have any sky to be reflecting in it. So let's switch it back to 1 maybe. Let's just add here our red object and add here a little bit of a trough, lower our roughness a little bit, so we add a little bit more reflections. It may be easier to see it with different objects, so let's switch our cube into a sphere. And now as we move our sphere, we should see some pretty nice reflections on top of there. Very nice. Alright, good job. Now we understand the basics of PBR rendering. We are rendering a material that has some color or texture. It has certain level of metallicness and certain level of reflectiveness or roughness. Now we have a bunch of other parameters that we can dive into. So let's maybe start with emissiveness, because that's what everyone loves about Unreal, just making things shine. How you can think about emissiveness is basically setting how much of the light is the object and material consuming and how much he is outputting and outshining of himself. If that value of emissiveness is higher than 1, that means he is outshining and outputting more light than he is consuming. So let's do that. Simple way how to do that is to take our color and multiply it by any value. Let's multiply it, connect it to our emissive color. We can keep the default by 0, which shouldn't change anything. And now we can promote it into a parameter right away. So promote to parameter, and let's call it now our emissiveness. And let's try it now with our blue material. Let's scale it down a bit and see how much it will reflect. So let's take our demo scene blue, find our emissiveness and increase it. And there we can see, depending on how we set it, we got ourselves some really nice lighting. Alright, that's it for emissiveness. So the only thing you have to actually remember is that if the value of emissive intensity is higher than 1, it's outshining more light than it is consuming. What you are also quite likely to encounter is a normal map. Normal map basically lets you project details from high poly mesh into a low poly mesh. This normal map, for example, has some pattern of squares and some noise inside them, probably for floor or whatnot. So if we try to connect it, we should see some pretty nice details on our models. And look at that, we got some really nice details. But let's say that I would like to have these only on some of my models. So I would like to set up here something like Boolean from Blueprint. So something like switch, which is exactly how it is called here in materials, that will let us switch whether it should use this empty normal or this normal. So let's do it. Let's put here a switch, and we want to change it in parameters. So we want to get a switch parameter, and let's call it should use normals. And if it's true, we would like to connect this texture, and if it's false, we would like to connect this texture. And let's connect output into our normal map. Compile, and by default it should all disappear, but if I click on my demo scene, I should find here new static switch parameters. Let's open it and enable. We got some very nice normals only on one of our materials. And the last thing you may sometimes encounter is world position offset. What it basically lets you do is to move the whole model in one of the 3 axes that we have in the world, so X, Y, or Z. Let's test it out globally. Remember the shortcuts. So we want 3 vector, so number 3 and left click, and connect it into our world position. And right now you can see everything nicely at the place that we put it, but if we add, let's say 150 on our Z and recompile, we should see it all jump up. Alright, good job. Now you got through another part. Now you understand pretty much all the basic parameters that you need to know to work with materials. Let's try to get into a little bit more advanced stuff with some math expressions. Let's start with something simple. I would like the model that has this material instance, specific material instance, let's say blue, implemented. I would like it to move up and down. So let's do that. It's very similar as you would do it with blueprints. So what we are gonna use is to move between 2 different positions. We want to have position that's 0 and position that's 200 on z-axis. That means 2 meters higher than the base of the model. And we want to lerp between them. So let's connect it and find here a lerp. Full name is linear interpolate. So let's just implement it here. And we have here now a new value. That's our alpha. If our alpha is 0, it's A. If our alpha is 1, it's B. So we just need to move between 1 and 0. Right now, since it's on 0.5, it's gonna be exactly in the middle. I'm afraid we are gonna have to disable our emissiveness, but we're gonna get into it with our material here. So let's set our emissiveness to 0 for now. And let's add here a parameter that's gonna solve it for us. So promote this to a parameter and call it just alpha. So now if I open my demo scene blue and move it up and down, we can see this really nice movement up and down. So now we have 2 ways how to do this. First way is to do it just purely with materials, and second way is to implement it with blueprints. And since this is supposed to be tutorial teaching you most important stuff, I'm gonna show you both ways. Let's start purely with materials, so we get few more math expressions in here. So first of all, we can get rid of our parameter for now. Let's hide it here, we are gonna need it later. And to set up movement purely with materials, we will need a time node. Let's get here a time node, and that time node we can take with a sinus. Sinus, I'm sure if you are familiar with, that's this wavy movement up and down. So that means this is gonna let us move between -1 and 1, but that's not what we want. We don't want -1 to 1. So we need to somehow transform it from -1 to 1 to 0 to 1. Luckily that's very easy to do. We can just add 1 to it. So let's add 1. And now we are moving between 0 and 2. So let's go a step further and divide this by 2. I personally prefer not to divide by 2, but multiply by 0.5. The effect is the same. And if we connect this into our alpha, we get some really nice moving up and down. Look at that. We got still this very strange flickering that seems to have some issue with rendering. Right now in Unreal, I think that's just me not having properly set up rendering. Alright, let's just move this away for our first way and comment it. And then what's very useful, with a sign, you can adjust the period. So if you want to adjust how fast or how slow the movement is, you can do it right here with a period. That's basically how often that wave up and down is moving, or what's the frequency is usually the correct term. Alright, I'm gonna stop messing with our world position offset because Unreal seems to be a bit upset about it. And let's demonstrate different way how to change parameters with blueprints. So let's do something more interesting. We would like to switch between our set color and some original color based on the value that we set up here. So let's just create here a new vector parameter and let's set this default on white. And what we want to do for our base color is to blend them. So again, the exact same thing. In the same way as you do in programming, with materials, you are pretty much always doing the same simple stuff. These are all the same math expressions, all the same simple stuff. How I like to think about it is that very complex system is just built from a lot of very small and simple systems. So if you look at anything in detail, it's actually very simple. With that, let's just repeat what we did here. So what we want to do is to do Lerp, linear interpolate, A to B, and connect it into our base color. By default, it's just gonna blend everything lighter, but that's not exactly what we are looking for. Let's set our default on 1 for our base color. And now I would like to do it with a blueprint. So let me add here a blueprint, actor, let's call it material changing PP. Once we open that, let's just add here some simple sphere. Let's say our demo red, and when we red it, let's replace our middle cube that wasn't even a cube anymore with our new model. There we go. And now what I want to do on my begin play, I just want to take my sphere and set parameter on it. Let's make first sure that we actually made it into a parameter, and we didn't, so let's do that. Right click, promote to parameter, and let's call this our color alpha. Default, our value should be 1. Remember this name, color alpha, it will be very useful in a bit. We can just, I personally prefer to just steal it from here, so let me just take it, copy it, and move right here. Now, in event graph, with reference to my sphere object, which means I write this one, I can set material parameter, and we are looking for scalar parameter, and there we go, set scalar parameter value on materials. Let's do this, and this is when the name comes into play, so let's just import here our parameter name as color alpha. Alright, and let's say on the begin play, I would like to switch it to 0, then wait for 0.2 seconds, switch it to 1, wait for another 0.2 seconds, and then move it all back. So we are gonna have this nice blinking of colors. Let's try it. I have switched my play into a simulate, so I don't have to add a pawn or anything like that. Just simulate the game, and look at that. We are very easily, without any proper material instancing, changing the simple parameters in the material. You can do that only with float or vector, but let's be real here. Unless you are doing something with textures, you probably don't need anything else than float or vector. Alright, that's all good, but I would like to make it smoother. And a simple way how to make something smoother with blueprints is with a timeline. So let's move our event graph here, right click and put here a new timeline. And let's call it our color changing timeline. Now if we open that, we don't want anything more complicated than adding a float track, having the whole length of 2 seconds, and add here 2 keyframes. One keyframe from 0 and value 0. Oh, we actually are starting on 1, right? Yes, we are starting on value 1. Then we want to go into 0 and value 0. No, time 1, value 0, excuse me. And we want to end on the same point that we started, because that will let us very easily loop it. So let's set our time to 0 and value to 1. Now if we want to have a bit smoother transitions, let's just right click and switch it to auto interpolation. And since I'm lazy, I don't wanna have to bother with connecting it here. I'm gonna make sure that I select my autoplay so it starts even if it's not connected. And I'm also gonna enable looping, so once it ends, it's gonna start right from the beginning. And with that, the only thing I have to do is to take my sphere, connect it on the update, and set our new track, which I should rename to our alpha blend. Look at this beautiful blending, it seems to work pretty well. As you may have noticed, I have to have a direct reference to the static mesh when I'm working on it. Here I'm doing it with a blueprint, but it would be quite annoying to getting references to all the static meshes in the game, in case I wanted to make a transition to all of them at the same time. Luckily, we have a thing just for that. The subject I'm talking about is a material collection. What this will let us do is to change some parameters like float or vector across all materials it is implemented in. Even if they don't have the same master material, even if they are completely unrelated, that will still be influenced, which exactly nicely suits our purpose right now. So let's create one. Right click here, create here a materials and material parameter collection. And let's call this our universal material collection. If we open that, we can see here scalar, which is float, and vector parameters. Here we are dealing just with a simple scalar. So let's open it and call it our blending alpha. By default, we know we have it on 1 and not 0. And if we open up our master material, the only thing we have to do is to replace our color alpha. Let's delete it with our material collection. Let's put it right here. Choose the parameter, which is blending alpha, and connect right here. And now let me show you a bit of magic. I'm gonna open my material collection here, and I would like to just move my blending. Look at that. When I'm switching between 0 and 1, they are nicely moving exactly between the values they have specified. Let's connect it into blueprints as well. So here, our material collection. We are gonna simply replace this set scalar parameter, and we are looking for set scalar value. You can see that there is no point in reference because we are referencing our material collection. So the collection we are selecting is universal material collection, and the parameter is our blending alpha. So nothing else changes. Let's just connect it as it was. Click on compile and play. And look at it. Changing globally on everything between 0 and 1. And what I would like to point out to you is that we are very nicely using the workflow we set up from the start. So here in our master material, with a global collection, we are blending between a color that we specified as the same one for all our materials, and then between a color that's a parameter that we changed for each of these material instances. That means that they are all blending on 0 into color we specified here, and then they are blending into color that we specified specifically for each of them. That makes really shine why this workflow is so powerful. Any changes that you make globally for everything, you do in the master material, and the changes that you want to do per instance, or the variant of that change you want to have for each instance, you do in that instance. Alright, good job, you got through another part. Now, let's make it a bit more interesting and talk about transparency and performance of materials. So for that, it will be easier to create a new master material. So let me do that. Let's create here a material and call it our transparent master, let's say. We are gonna need some models for it. So let's put here a plane and move it right up here. So what we would like to see is cost of different materials first. We can find that under lit and optimization viewport, shader complexity. Generally, we can see everything is pretty good. It's green, green means good. We can say it right here. There is a pixel cost and vertex cost. You don't really need to worry about which does what necessarily. Let's just focus on having both of them as low as possible. You can also preview them in the material editor by selecting here a performance or platform statistics and statistics. There we go, we can see 161 instructions, very cheap, but we got nothing here. Let's start by just adding here some color. And now let's look into shading models first. The only thing you need to worry about right now is your default lit material and maybe unlit material. The difference is that default lit material can accept the light from lighting system made in Unreal, so your regular direct lights, sphere light or whatever light you are using. And then you can have unlit. A huge advantage of it is that it's much cheaper, but it can't accept light, so you kind of have to figure out your trades-off there. Let's right now switch back into default lit and look at what's more important for us right now, and that's our blend mode. And we can see here opaque, which is what we are using right now. That means no transparency even mentioned. Then we have here a modes for masked and translucent. We can start with masked. Right now you can see that we just switched to a masked material and the instruction count didn't actually change that much. Masked material, if you can use, you should definitely use masked rather than transparent. The reason is that you are thinking about transparency rather as a boolean instead of a float. That means pixel either is visible or isn't visible. There is no in between. Let's set up that. We can add here a float. And right now, if we connect it into a 0 on our opacity mask, the whole object disappears. Nothing visible. If we set it to anything higher than 0, it's gonna be, seems like there is some threshold. But generally, if we set it to 1, it's gonna be completely visible. Maybe it's if it's 0.5, not sure exactly. But the point is that it's either is completely visible or isn't visible. Luckily, we can use at least textures for that. So if we disconnect it, we can put here a texture for our mask. Let's put here a texture sample and find here some interesting alpha mask. Let's try this Android icon. Connect it from our alpha channel into opacity mask. And we should see some pretty nice icon. Let's see. Look at that. Looks pretty good. Let me switch back to lit. And we can see some fairly nice droid. Don't see much issues, no overdraw, as if we can look at our optimization viewport. We don't see anything going over it. There is nothing being rendered on the part that is not visible. It either is visible or isn't visible. Still fairly cheap, especially if you combine it with an unlit material. Now let's get into actual expensive stuff. Let's switch this transparent material from masked to translucent. Translucency is pretty amazing. It lets us set any value between 0 and 1. So if I put here my constant, 1 float, we can see that any value I set here between 0 and 1 will let me switch between different modes of transparency. But our instruction count doubled at least. Which wouldn't be that bad. The problem is what comes after that. Let's switch back to our optimization viewport and find our shader complexity. And the problem is not actually that the material is more expensive. The problem is everything behind that material. Because what has to happen is that it draws the material it is drawing and then everything behind it as well. So you can't occlude it. You still have to see it, and you have to see it with additional rendering on top of it. So if it's just one like this, like one window or whatnot, it's not that much of a catastrophe, but it's already starting to get there. But imagine you have here more of them. You are looking through multiple layers, which is not that unrealistic scenario. There is now 4 in the row, which is still not completely unrealistic. Imagine that you are looking through the window and also through the glasses of the character or through the hologram on the gun. Bunch of stuff that could happen. And now if we actually look into our optimization viewport, we will see something really bad. Look at that, it's almost white. You can see it's yelling at me. Extremely bad, don't go there. And the less layers we look through, the cheaper it is to render anything. The more we look through, the more expensive it is. That's the real issue with translucent materials. The layers, it gets stuck on top of each other. If you are working with opacity mask, it doesn't matter because it's not rendering the scenes that it's not rendering at all. Alright, now I hopefully scared you enough from using transparent materials. And just to be clear, I am not saying never ever use transparent materials. Just be very careful with them. And if you are working on a low-end platform like mobile VR, mobile, or anything less than high-end computers pretty much, or like modern computers, you should be very wary of using it and rather use either masked materials or try to find a different way how to fake it, like with particle effects or whatever way you can. Now let's start with some more interesting masks. So for example, what I can do is to take my texture coordinates and use it to create some gradient transition. So let me do that. Let's find here a texture coordinates, and if you just look at it, we can see we have here two values that are fighting each other. We have here green in the left lower corner, and we have here red in the right upper corner. They are kind of fighting. We can see it right here. They are trying to get to each other basically. But what we can do is to separate them with a mask. So here, if I separate it, I get a really nice transition from complete red, in this case complete 1, to complete 0, which is very useful for my opacity. You don't really have to worry about any texture, anything like that, and you can adjust all this with parameters. So you can program with blueprints this transition from full to lower, etc, etc, etc. Would be way more difficult to do it with textures. Not impossible, but this is much easier and cheaper. And also, just to be super clear, if we switch it to green, we get our movement up and down. So let's start with our movement up and down. And first I would like to increase contrast. That means a difference between white and black, 1 or 0. And we can luckily do that with power. That's basically just contrast. If you let me connect it here and visualize the model, we should see quite nicely the difference. And if we increase it to something crazy like 5, we can see that the transition is still quite smooth, but not as smooth. And there is way more on the black part and way less on the green part, on the red part. But now I can also just increase it. So let me multiply it again. Let's multiply by 10 or 10 by 100. And here I have moved my transition, but still kept the intensity. And you can play with these values however you wish. You can expose them into parameters and change them however you wish. What we can do is to just reverse the value and get the bottom. Easily we can do -1, that's gonna let us multiply by 1 minus, which is the exact same thing as if I did multiply by -1. Alright, and now when we are looking at it, I would also like to kind of my left and right, and we already know how to do left and right. We can just switch it to R, but if we add it just here, we get just one side. That's not what we want. What we can luckily do is to do the exact same thing we are doing here. Let's just move it all down, switch from green to red, and multiply these two together. There we go. Apply, and we get nothing. We actually do get something, but it's so weak that we can't even see it. Well, with that, let's just adjust our setting. We are gonna decrease our power. Well, okay, not that much. I still am quite powerful, as you can see. Increase our multiply, apply it, and voila. Well, it's applying quite long. That wasn't really working for my effect. Nevertheless, there you go. There you can nicely see the effect that we needed. We have blend now from both sides. And now I'm obviously transitioning from opacity. But what I could also do is to use this as a Lerp. So just imagine that this is not a transparent material, and I am lerping between two colors. So let me put here different color. And what I'm trying to do here is to find here an exact value between them and using this whole setup as mask. Doesn't have to be for transparency. And if we look at it, we get exactly this. And I want to switch colors. Well, just switch A and B. I want to adjust the transition with blueprints. All that can be easily set up by changing the numbers here. Let's get on to the last thing, and that's manipulating textures. And we can demonstrate it with our opacity mask. So let's just start by putting here a texture we already worked with here. And you can see, even though I have connected my opacity, it's still keeping the blend that I set up. Very cool, quite cool. I'm gonna quickly remind you the performance. Since we are using the transparency, we are drawing all these things around it. So if I look at the optimization viewport, shader complexity, all the things around it, even though I'm rendering just this thing. But what I can do is switch it to a masked. And now I don't have it connected, so let me connect it. And once I connect it, we should nicely see that we are not having any overdraw. We are just drawing this scene. If I quickly switch back to translucency, we are drawing the whole thing. And here we have some serious overdraw. Alright, so let's talk about texture manipulation. So what you will very likely want to do is to just change how many of them you are using here. So let's say you are adjusting the scale. Very often you would do that with landscapes or when you want to just adjust tiling on the wall. So what you have to start with is getting your texture coordinates and connecting it right here. That's just getting the idea of the model. And what we can do right here is to just adjust our tiling. So if I set it to 3 times 3, I get this pretty nice 3 times 3 points. It's always X and Y axis, or U and V in this case. If I switch this to 1, I get it along just one axis. Quite stretched, but we could probably actually adjust it with scaling. In case you really wanted to use it, you could probably figure out a way how to do that. But now, what if I want to do it with a parameter? Since I know that these numbers are 1 on 1, this is my 2-vector output, 1, 1, I can simply take that and multiply it. So multiplying by 1 keeps it the same. If I multiply it by 2, it switches it to 2 times 2, which doubles it. Multiply by 3, switches it to 6 times 6. Oh, 3 times 3. Alright, but what if I want them to move? Let's say that you have there some billboard or some TV playing. You may want to have your mask moving around. Let's add here a pen connect it in the UVs. Right now it doesn't do anything, but we have here a 2-vector parameter that can be adjusted however we wish. And once I compile, you can see here very nice moving up and down. And it all works with our scale as well. And you can also see how that mask is still using its textures parameters. Because I didn't connect it here with my texture coordinates, as this texture mask, these little guys, are moving around. It's just blending them into a color, which looks quite cool. Alright, sometimes you may not want to move, you may want to rotate. Replace our pen with a rotator. You can achieve the same effect with rotation. And last thing we are gonna cover are your good old math expressions. So that means adding something together, subtracting, multiplying, and dividing. We already pretty much know all of that. But what you may not realize is that you can do it with textures as well. So what you kind of have to understand is that texture is just basically a value between 0 and 1 for each of these pixels, each of these parts. So what I can do is to just each of these little values multiply together or do simple math expressions with them. So let me just do that. I'm gonna change my texture here to draw it again. And I would like to take alpha from here and add it to alpha from here. And look at what I get. I get this weird mix of droid mixed with my weird bot that creates very strange abstract. Okay, this looks just like some alien photo. Let's ignore this one. This is very low resolution Android pic. It's like 64 by 64. That's why it's so blurry. Ignoring all that, I can do something else. I can, for example, subtract it from each other. So I would like to subtract this one from this one. So the only thing that will remain is this very weirdly laughing person. Understandable. That's actually pretty funny. Alright. Here I am using just some random textures, but with the textures that actually serve your purpose, you could find here use for some very interesting things. In the same way, if I switch it around, we can see a person that's being in the shadow of it looks like it stands in front of this android. Right, and similar things we can do with multiply. Multiply tends to be very useful because it basically takes all the non-existing parts, all the black parts, so renders them as 0 because anything times 0, so anything black is 0, and anything that's a little bit higher than that will just find its own value. We end up with that. And dividing, I am not sure if I actually ever end up using dividing in this case, but it may be for very specific use case. You can see here I don't think it even is, well, it added probably a bit of weight right there. It's at least for me, it's difficult to visualize, but it may be easier for you, who knows. And now, one more thing, I would like to combine it with my previous mask. So let's just multiply again with the mask from here. And so I get this nice blurry radius. Oh god, what have I created? Okay, yeah, that's pretty messed up. What the hell did I do? Let's just do it with something else. Let's just do it with this. And here we will get what I actually wanted. And that's blending on my nice character. So the center is the most visible, ends are less visible. I could play with it to actually make it blend and adjust these parameters, but I'm gonna leave all that for you to play with and have some fun. Alright, that's about it. You got through it, guys. So good job. You should pat yourself on the shoulder, all three of them. Thank you for paying attention. I hope you really understand the basics of materials now. If you are interested in learning more, I'm gonna leave some recommendations down in the descriptions, what could be interesting to study, mostly Epic official stuff. Or if you are interested in stuff like low-end performance optimization, making a lighting system with Unreal Engine, I have made a tutorial or video covering that, so you have a link in the description for that as well. And that's about it. I hope you make some cool games or cool projects. So good luck with everything and see you around. Surfancy out.